Thank you very much. So today we're going to be talking about gaining visibility and accountability in the cloud. Now, I'm Ryan Nolette, and I've been doing different kinds of purple, blue team stuff for about 15 years. One of my main joys right now is taking the things that I've learned and turning them into open source tools for either teaching or learning for either junior analysts or senior analysts who have not been introduced to like the new emerging technologies like the cloud. This is my colleague, Marta.
Hi, I'm Marta. I work as a software engineer at WASU, and outside of work, I help organize tech events in my country, Spain, and I am also a diversity in tech advocate.
And as you can tell, our project is a bit international. So what I want to kind of go over in this is kind of a three-stage approach. The first one is just a brief explanation of kind of the framework of methodology that we like to try and build our learning tools in. We're going to go over, the basic questions that you need to ask, the common techniques that we're seeing right now, as well as some common tools and their AWS equivalents. Now, if this sounds familiar, Lily earlier did a wonderful job of talking about a lot of these topics. We're going to be taking it a bit step further at a little bit lower level of how we're actually going to technically do it. Also, we have an end-to-end example we're going to walk you through, so a real-world example that I took out of a production environment. And best of all, we are kind of announcing the release of version 2.3 of our Detonation Lab that we posted last year or so on GitHub. It is basically some automation that spins up a full topology for you with some canned attacks and ingests logs and all that good stuff for you. So you can learn that when you poke your infrastructure here, the logs light up here, here, and here. And it's a great learning tool up there on our GitHub. So the first thing is kind of the framework, right? We want to answer three simple questions usually: who, did what, and when. And by answering those questions, we are adding accountability to actions that occur in our environments. All right, this is kind of that iterative cycle that you do. Who knows about like the OODA loop or the threat hunting loop or even the incident response investigation loop. They're all the same idea. We start off at a point, we keep iterating through our list of questions and continue. So some of the techniques that are common that we're using are the basics of OS hardening. Choose whatever standard you like, whether it's CIS, NIST, Batman's secret plan, whatever you guys want to standardize on, that's what you kind of used. And that's the same thing with configuration management, right? We want to have some form of baseline drift analysis, right? Because if we don't know what's abnormal, how do we define, if we don't know what is normal, how do we define what is abnormal? So having config management helps with that. Same with identity management, right? Who actually belongs talking to my stuff? And finally, we can look at things on the endpoint or the workload, such as process monitoring. And the whole goal is taking these techniques and tools and putting them in those two buckets, right? Visibility and accountability. If you can't see it, you cannot account for it. So what we want to do is keep increasing controls, whether they're technical controls or policy controls, and you want to continue to increase them until you can start to account for everything that happens in your environment. This is an ongoing process. No one ever gets this 100%. If you do, I will buy you a beer and ask you so many questions, right? Because this is an iterative process. No matter how long you've been doing it, constant new technologies, constant new events in your environment, constantly trying to re-answer those questions of who, did what, and when. So some of the common tools, this is a bit more zoomed in than Lily's was, but we wanted to try and make cloud a little less scary. So, who here has ever worked on an on-prem enterprise, right? Do any of you, use DNS in your enterprise? I see somebody shaking their head no, and that's terrifying. So I'll go with NetFlow next. When you're doing an investigation, you need to see who's talking where and things like that. So collecting NetFlow is incredibly important. In an AWS environment, that's VPC flow, right? It's network communications that are occurring. And what we're going to kind of do with these tools and techniques are we're going to give you end-to-end example. This is the use case of this end-to-end example. Kind of the goal is you're always recording logs and events that are occurring in your environment. So the idea is kind of squirrel away your logs. And the idea is that as activity happens, whether or not you've approved that activity, you're able to at least see it happening, right? Whether or not you're looking in that log at this time, that's really up to your process. But the strong part is you need to have those logs. So if you need to go back and check, you can see them. This use case is something that has happened many times, different incidents I've had to respond to. And the real thing is a kind of a conflict of interest, right? Your guys that are developers, DevOps guys, whomever, they don't get paid to worry about the security implications of their workflows, tools, their product that they're producing, right? Their boss gives them a deadline for this Friday to push the new version of the application to production. That's what pays their mortgage. They're going to do the easiest way possible to get that done, right? So in this use case, we had a developer who needed to push the prod, and they went and looked for a bunch of online tools to see if they didn't have to reinvent the wheel and could just use somebody else's package. They only checked whether or not the tool did what they needed, which is something weird with MongoDB. And it worked. It did exactly what they needed, and that's all they cared about. They pushed their stuff to prod, they're happy, their boss is happy. I die a little inside, right? Because what they ended up doing was they downloaded a binary that was backdoored with a crypto miner. Now, the static defenses that we had never seen this kind of variant before. So they weren't able to stop it right off the bat, right? But because we're recording this activity happening at all times throughout this entire process, we're able to remain vigilant. SecOps is going to be able to see this activity and is going to be able to defend based on that activity. So going to the Detonation Lab, this is the rough topology of what it stands up. It's a CloudFormation template, which is, who's familiar with CloudFormation, right? All right, who's familiar with Puppet or other configuration automation and deployment things? Same overall concept, right? It's infrastructure as code. We're going to use this to spin things up. So the CloudFormation template we wrote takes about 7 minutes from soup to nuts, and it creates this topology in a single VPC. Now, we have a public and private subnet. The public one has our Bastion host in it, and we're going to use that as a jump box to get into our private subnet that has 4 systems. Now, the reason why we're doing this 2 subnets is because we're going to do terrible things inside this environment, and I don't want to get sued. I don't want to bring down production, and I don't want to get sued, right? So what we have here is we have a Linux victim, a Windows victim, a red team attacker, and a Wazoo server. And we'll get into that in a little bit, right? What we're going to be doing using this environment is we have some pre-canned attacks in there, right? Nothing overly terrible, but things that you can fire off as a junior analyst with kind of a click of a button, and then it will pull in logs. Now, how do we really pull in logs in this environment?
So in order to create an automated logging pipeline, 3 elements are necessary. First of all, an Amazon service to monitor, which can be GuardDuty, AM, or Messi in this case. Then, an Amazon CloudWatch rule needs to be configured to monitor those services and forward the events they generate to Amazon Kinesis Firehouse. And Amazon Kinesis Firehouse needs to be configured to guide the events it receives from CloudWatch into an S3 bucket. On the other hand, VPC and CloudTrail can be configured to directly guide the logs into an S3 bucket. And finally, Amazon Inspect scan results can be fetched by querying the AWS API. The Wazoo manager is the one in charge of doing those API queries and reading the data from S3 and indexing all that into Elasticsearch.
So what services are we looking at? Well, as kind of came across, there's hundreds of services to look at that do different things. So here's a couple of the common ones that are usually across the board, right? You have S3, which is just your storage area. We have GuardDuty, which is the detection service that's kind of configured and slanted to look at cloud-based behaviors versus on-prem behavior, and things like, Inspector and Macy, as we mentioned. Now, these services generate a lot of content and data, right? But how do you get access to this data and kind of make it part of that automated pipeline so it's constantly ingesting stuff as you go?
So for all those of you who don't know what WASU is an open source kit that includes features such as active response, vulnerability detection, and file integrity monitoring. And it can also be integrated with external services such as VirusTotal and AWS. But how does WASU read data from AWS? It uses Python and Boto3. Boto3 is a Python framework to interact with the AWS API. And the process it follows consists on iterating over all files in a bucket, parsing each one of those files, and sending WASU these parsed contents in order to analyze it and raise security alerts, which will be indexed in Elasticsearch. This snippet here shows a very simplistic way of doing this iteration over files. It basically uses the list objects version 2 function, which returns the files to iterate over under the contents variable. But there are a few challenges with this proposed solution. First of all, how to filter by region and account, and how to select where to start filtering, so where to start processing. And also, this function returns 1,000 elements. But what about the others? So let's start by filtering by count and region. So this is how an AWS path name looks like. As you can see, it includes both the account ID and the region. So in order to filter that, it's only specifying a prefix, which will include both the account ID and region that we are interested in. But we are still getting logs that we are may not interested in. So how to deal with that? As you can see in the path name, the date is also included. So in order to select where to start, we just need to have a longer prefix, including that date. And now that we know how to filter a single account and single region, let's see how to iterate over all of them. So the idea here is to group all the accounts and regions that are available in all the file names and iterate over that. But since doing that grouping can be quite expensive in terms of performance, we can ask Amazon to do it. And this is what I'm doing in this first snippet. As you can see, calling this function with an empty prefix will group by the first item in the path name, which is AWS logs. If I call this function with the first item of the path name, it will group by the second one, which is the accounts ID, and so on. Having this function is straightforward to iterate over accounts and regions. And finally, how to fetch all the files and not just the first 1,000. To do so, we need to do pagination over results. And the list objects function gives us a value is completed to know whether the result is complete or not, and some continuation tokens to do the pagination. So in this snippet, I have used a few Python tricks that I highlighted in the slide and which are available in the links if you want to know more about it. And well, finally, now that we know how to iterate over files, let's see how to parse each one of those files. So there are a few challenges when parsing file contents because each service logs in a different way. For example, logs coming from Firehouse can be directly parsed with a JSON parser because each event is a JSON itself but a file can contain multiple events. And on the other hand, VPC flow are CSV. And finally, CloudTrail logs are valid JSON files. And some keys can have different data types depending on the event. For example, a same key can be both a string and a dictionary. And that can give problems when indexing in Elasticsearch. Also, Amazon aggregates some events, but since Elasticsearch can't work with arrays of dictionaries, we need to ungroup this event into multiple ones. And finally, logs can be both compressed or decompressed. So we need to make sure that a log is decompressed before parsing.
So it sounds a little complicated, right? A little complex. Well, we kind of got a present for you, all right? That's a live working example in production, right? That you guys can all see. It's open source. So if you want to repeat some of this, you can use the source code that does exactly this. Also, one thing to mention about the last couple of slides with code, as we saw up on there, there were red boxes that went over blank spots. There's actually stuff on there. It just seemed the colors didn't show up on the screen. So check the slides afterwards and you can see the actual code snippets as you like.
Thank you, Ryan. Well, as I said before, this is how a CloudTrail log file looks like. It's a JSON object which contains a single key records, and this key is a dictionary. It's an array of dictionaries, each one representing an event. And this is how a log file coming from Firehouse looks like. As you can see, it can be directly parsed because it's not a JSON, it's multiple JSONs in a single one, so in a single file. But Python was covered because Python has a raw decoder JSON which can extract a JSON out of a string. So now that we know how to parse these logs, what to do with them?
So what we need to do with the log content is, start mapping and correlating it, right? Because we just got a ton of data, which we just did a bunch of work on ingesting, parsing, and doing all those things we care about. Well, now we need to map it. In this case, I'm using a kind of model. And what I'm doing is I'm taking specific attributes from the data. So, you have a field for account ID, your ARN, your principal ID, anything like that. And I'm taking those sources and I'm mapping them to entities and features inside my model. This is allowing me to do very quick, common correlation. And this is also going to give me the ability to start creating some visualizations that are going to help junior analysts or people unfamiliar with the little minutia of the logs, right, and help kind of bootstrap them and get them running. So what we did in the Det Lab is we created a bunch of different visualizations and we turned them into a dashboard, right? It all automatically gets ingested when you launch the CloudFormation template, and it starts ingesting data which populates these dashboards and visualizations. We started with a couple of really common ones, like who are our top talkers for destinations, right? That's something everybody likes to ask when you're doing an incident, who are they talking to? Next up, we're also kind of using some of the AWS services like GuardDuty, which are my top talkers per instance ID, right? We're trying to find our problem children and give them a paddling, right? So we also drop something down for a table, which is going to pull the account ID out of the GuardDuty findings and starts ranking them, right? We just created a digital wall of shame. Feel free to put it on the front door of your showcase SOC. It will be very effective that way. And last but not least, CloudTrail, right? We spoke a ton about CloudTrail today in a bunch of the talks that came previously. The event names in your CloudTrail data matter because until you define normalcy, how can you pick out abnormalcy? So this is going to show us what are the most common CloudTrail events in our environment. So then when we get a spike in data, we know that there's an anomaly there, right? We may not know whether or not it's malicious, but we sure as hell know it's suspicious and should go get looked into because it's anomalous compared to our baseline. Now, this is our end-to-end example. All of these images are taken out of the dashboard that is in the Det Lab. So, as I mentioned earlier, we put all these systems inside the private subnet of the VPC, so they wouldn't be accessible to outside resources, and they don't have collateral damage. Well, sometimes I forget those things and put them on the public internet just to see who likes to poke at it. And there may or may not have been a foreign power that will remain nameless who decided to poke at my stuff and try to pop it. So I here found a spike in network traffic in my environment. I'm not using it, it's just sitting there, so there's an obvious mistake. I go and I dig into that, and I find this .75 IP address. So what is this? How is it talking out? Why do I care? Those kind of things. Well, we can take that .75 address and we can search. So in the Det Lab, there are GuardDuty, Macy, Inspector, VPC Flow, and a bunch of other AWS services getting ingested and indexed into the Elasticsearch or Elasticstack. And I can search any of those sources against that IP address, but I want low-hanging fruit because I'm lazy. I really don't want to dig through a bunch of logs, and I'm lazy. So I'm going to use a curated source. GuardDuty Findings automatically give me detections. They are to show me that something is most likely a known bad source, right? It might not be everything I ever could have wanted for a detection service, but I, as a senior engineer, don't have to follow this anymore. I can hand this off to a junior analyst because it has data already marked and they can parse through it. So if I look at the GuardDuty findings, I can see they're associated with a Bitcoin miner. Now, why do I care about Bitcoin miners? We spoke a little bit earlier about things like billing costs and whatnot. People are trying to basically steal resources from you and generate coins for their money. Now, we know what system this happened on because we're able to follow that external IP address directly down to what host inside my environment did this. Now, in this case, we're looking at an instance because the instance ID is associated with the finding. But this works for all of your cloud workloads, right? The serverless workloads, your container workloads, all of those things are going to have similar attributes that you'll be able to do these correlations with. Now, if I look down at the system, I want to know what actually happened. So I'm going to use Wazoo in this case because everything in our environment is either AWS native or open source. So you don't have to pay for things. And what I'm going to see here is that I have an entry in my netstat table for this instance where this .75 IP address goes. Now, this also tells me what process initiated that network connection. In this case, it's something called pip.3.7. Now, who knows what the latest version of Python released is, right? 3.7.3. So in my environment, pip 3.7 seems kind of normal, right? Except in my environment, I'm only using Python 2.7. It's legacy, do not judge me, right? So I know this is a baseline of things. So I don't have Python 3 installed anywhere. So I'm going to poke at it and look at it. Did a developer decide that he wanted to work on optimizing our code and push things forward? Or did something bad happen? Well, what Marta mentioned earlier is that Wazoo's kind of nice where we're able to integrate with external services. So we're pulling in all those AWS logs already, but we're also able to make calls to services like VirusTotal. So I can take the hashes of those newly written files that I see here, and it automatically does a query for me. It doesn't upload anything to VirusTotal, so don't have to worry about that. It just does a query for the hash. And I'm able to see quickly that it's 53 out of 68. So either they're doing Bitcoin mining or blockchain, who knows? It's the same stuff, right? And basically they're just trying to do bad things. So with all this cool information, we're able to answer kind of the who did what and when, but there's an additional question, right? So the who, what, and when is the iterative process that we're doing for this investigation. But you still have to do some kind of root cause analysis, right? How many of you have a boss that asks you to do attribution, right? And not just attribution outside your company, but I mean attribution of how the hell they got in. So what we're using here is a couple of different services. Marta mentioned how we pull in inspector scan findings, and we are running inspector in the environment. So that's an AWS native tool that does, vulnerability scanning, compliance scanning like CIS and stuff. But we also have some open source tools that we're using. Our good old trustworthy Nmap, tell me what ports are open, possibly try to guess some of the services that are running on those ports. And then we have a tool that I like out of Cali called Necto. I've only ever seen it in writing. It's probably Ninja Turtles. But the idea is this maps up things that it scans and finds against with CVEs. And what we can see in our environment is this is a directory transversal vulnerability, which eventually ends in remote code execution. Now, this is why you don't copy and paste things off Stack Overflow. For any of you who are developers, that's a paddling. Because I know this for a fact because I copied and pasted this off of Stack Overflow into the environment just to see what would happen, right? So we know what they're doing, how they're going against it, and it's a great teaching tool, not just for my junior analysts, but I can also show this to my DevOps team and show them kind of the worst parts about if you just copy and paste things without actually looking at what it does. Now, as kind of a recap, everything that we did through that entire investigation process was an iterative loop, right? The iterative investigation loop. We are constantly trying to add additional visibility, right? The first time we ran through it, all we had was CloudTrail and VPC flow. That only answered so many questions. So we added another visibility control, right? That additional visibility control was GuardDuty. Now we have some detection stuff. Then we added Macy, then we added other services. And by adding all these new visibility controls, we're able to start assigning accountability of who did what and when, right? Now, one thing that we really didn't mention is stuff about the attacker, right? What kind of person would try to break into somebody else's system just to mine Bitcoin? Well, it's somebody that has a very tough life cycle, right? In this case, we have a guy who's just told pretty much they can work as hard as they want and everything will come true for them. In this case, it doesn't. So what do they start doing? They look for other ways to make money, right? They find out about Bitcoin, they find out about all these different technologies, and they start using them. They start making some money, they're all excited. They end up buying the only Lamborghini in Eastern Europe. So they kind of get investigated for tax evasion or whatever, float your boat. And they eventually flip and go to the Witness Protection Agency, thus beginning the cycle again. Now, I really want to thank you guys for all the attention that you gave during this. And I want to remind you remember the motto, flag it, tag it, and bag it. Give those malware the double tap. And thank you very much, guys. We're out of time, so have a good one.
Thanks.